In the skies over a contested land, a US military drone was on a mission unlike any before. This drone operated with unprecedented autonomy, its human operators miles away, watching screens as the machine made decisions. Tasked with tracking a high-value target, the drone's AI sifted through data, processing information at superhuman speed. It locked onto its target, confirmed the identity, and calculated the risks, all in fractions of a second. The human operator had the final say, but the machine had already done the heavy lifting, presenting a kill or no-kill recommendation with a confidence score. The line between tool and decision-maker had never been so thin. This was not science fiction, it was a turning point in warfare. For the first time, a machine was a partner in the act of killing, gathering evidence, building the case, and aiming the weapon. The human role was reduced to final consent, a veto over a decision already made by code. This operation revealed a profound shift. War was no longer about bigger bombs, but smarter algorithms. The revolution began not with a bang, but with a stream of data. Autonomous systems are no longer theoretical, they are active on the battlefield today. They are changing the rules of engagement, the speed of conflict, and the very nature of war. The ghost in the machine is real, and it is armed. What happens when the connection to the human operator is lost? What if the machine is given full authority to pull the trigger? This incident was a glimpse into a future arriving faster than we can prepare for. The implications are staggering, forcing us to ask new and uncomfortable questions. Autonomous weapons are not just tools, they are changing the very nature of decision-making in war. The silent revolution is underway, and its consequences are only beginning to unfold. The battlefield is no longer just a place for soldiers, but for algorithms. The future of warfare has arrived. The single autonomous drone is just the beginning. The next evolution is the swarm. Imagine hundreds of small, interconnected drones moving as one, sharing information and overwhelming defenses. Programs like the Pentagon's Project Replicator aim to build thousands of cheap, expendable autonomous systems. These swarms can map battlefields, jam communications, or attack from all directions, making them nearly impossible to stop. In the skies, AI-powered fighter jets are being tested, capable of maneuvers and split-second decisions no human could match. On the ground, drones like Ukraine's Soccer Scout use AI optics to autonomously detect and target enemy equipment day or night. These systems rely on sensor fusion, merging data from cameras, radar, and more to build a complete picture of the battlefield. The result: machines that can see, hear, and understand the environment better than humans. This is what makes autonomous weapons truly revolutionary. The era of the heroic fighter ace is giving way to the era of the superior algorithm. War is now about who has the smartest code. The battlefield is evolving at machine speed. Every complex system has a weakness, and for AI weapons, it's in their code. These systems can be hacked. An enemy could turn a drone swarm against its own side. Beyond hacking, AI can be fooled by simple tricks, adversarial attacks that manipulate what the machine sees. A few stickers or a clever camouflage can make a tank invisible or a school bus look like a target. The most expensive AI weapons can be defeated by cheap, creative tactics. This creates a new kind of asymmetric warfare, where ingenuity can outsmart technology. The intelligence that makes these weapons powerful also makes them fragile. The silent revolution is built on a foundation that could crumble in an instant. Military AI isn't just about pulling the trigger, it's about thinking strategically. AI sifts through oceans of data, troop movements, satellite images, intercepted communications, finding patterns humans would miss. Projects like the Pentagon's Maven and NATO's Prometheus use AI to analyze video, predict enemy moves, and run thousands of simulations. This gives commanders a critical edge, letting them act proactively. But AI offers probabilities, not certainties. The ultimate decision still rests with a human, but over-reliance on AI's logic can be dangerous. The digital general can't understand the human cost of its calculations. AI provides the what, humans must grapple with the why. The future of strategy is a partnership between human judgment and machine speed. AI learns from data, and if that data is biased, so is the AI. On the battlefield, this can be fatal, misidentifying civilian vehicles as enemy targets. AI makes decisions in milliseconds with no hesitation or context. Flash wars could erupt as automated systems react at inhuman speeds, all based on flawed logic. These errors are systemic, not random. An AI trained on incomplete data will make predictable mistakes. The result: tragedies programmed from the start. Accountability becomes murky. Who is responsible for a fatal mistake? The programmer, the data scientist, the manufacturer, or the commander? Without clear accountability, there's little incentive to fix the problem. The risk of algorithmic atrocities grows as AI takes on more lethal roles. The cost of error is measured in lives. War has moved to the digital realm, and AI is its most powerful weapon. Nations deploy AI bots to probe and attack critical infrastructure, power grids, financial systems, communications. These attacks happen at machine speed, causing chaos in milliseconds. Defense requires AI too, a battle of algorithms, fought beyond human comprehension. AI hunters patrol networks, learning normal patterns and isolating threats instantly. Offense and defense evolve together in a perpetual game of digital hide-and-seek. The ultimate fear: an AI that invents new cyber weapons, exploiting unknown vulnerabilities. Such an AI could unleash attacks no one can defend against, holding nations hostage. In this invisible war, there are no front lines, only nodes on a network and the AI that hunts them. The digital battlefield is everywhere. A new arms race is underway, not for bombs but for AI dominance. The US, China, and Russia are pouring billions into military AI, each seeking the edge. China's military-civil fusion rapidly integrates tech innovations into its armed forces. The US leverages tech giants and agencies like DARPA to stay ahead. Unlike nuclear weapons, AI can be copied, stolen, and proliferated, even by rogue groups. A cheap drone with open-source AI can become a deadly weapon. This rapid spread makes the world less stable and more dangerous. The pressure to deploy untested systems is immense, risking reckless decisions. As nations race for smarter weapons, they create a web of interconnected systems that could spiral out of control. The pursuit of technological advantage is pushing humanity toward an uncertain future. The final question is not about technology, but morality. Should a machine ever decide who lives and who dies? Groups like the Campaign to Stop Killer Robots call for a ban, arguing machines can't understand the value of human life. They warn that delegating killing to algorithms strips war of its moral gravity. Powerful nations resist a ban, claiming AI could make war more humane, unbiased, unemotional, and precise. They argue that banning these weapons is futile, as adversaries will build them anyway. Humanity stands at a crossroads. What technology should we build? Not just what can we build. The development of autonomous weapons forces us to confront our values. Does killing require human conscience? The technology is here, and the debate is no longer theoretical. The decision we make now will define the future of warfare, and our own humanity.